chat when I saw that. So basically, this Unit 2 test will consist of 9.6, 9.7, and you're talking 2 to 3 calculator questions from there. And then 10.1, 10.2, 10.3, 10.4, 10.5, and 80% of the questions are going to come, 80% of your test is going to come from there. So 2 to 3 questions from here. So you're talking about two to three questions there, 2 to 3 questions there from the calculator, and then the rest is going to be identities from 10.1 through 10.3. Why? Because those are the heart. This is the heart of the identities. And if you can do these, then pretty much you can apply the identities to these 2 sections, and you can, most of the time you're going to need a cheat sheet anyway. And on this test, make sure you have a cheat sheet. Okay, how do you find a cheat sheet? It's very simple. You go to handy dandy Google, and I like the green one. And what do you mean green one, Hubert? Go to Google and type in Trig Identity Cheat Sheet. There's a green one that I use, and hit images. Well, it's outlined in green, and I don't know why I can't find it right now. Usually looks like that. Maybe they may have changed it. It's usually in green. There it is. Now, how you print this out is fine. Look it up, see if you can find a cheat sheet. There it is. Might want to save it and then blow it up, save image as Trig Identities, then go to your handy dandy Word. Oh, while I'm at it, not that it applies to any of you, because most of you are going to take 140 either next semester or take my 140 in the fall. I meant the summer. But if you want to take one of these courses for math, Math 103 will transfer to Clemson as a math or an elective. If you're an engineering or science, which most of you will, that will transfer as an elective. And Math 120, some of you may need Math 120 for some of you business majors or some of you people that are in a field that has research in it. So I'm teaching that one also. So, and I think I may be teaching, I asked for a 140, teaching 140 like this format, the sync. And she says, well, I don't want you to have 4 syncs. I'm like, good gosh. I'm the only one that does syncs well, and why don't you let me do them? But anyway, I asked for the 140, but I don't know if I'll get it because I'm already teaching business calculus right there. But that's a good prep. If you want to take my summer 140, that would be a good prep for it. If you never had calculus before, you could transfer that 130 as a elective. You know, that would be a good prep for 140. But it's up to you. You know, I'm just showing you what I'm teaching next semester. And there's one course not on here. She's going to decide and let me know. It's either going to be another 120 or she may give me that 140. I don't know. Who knows? It all depends on how the numbers fall. But anyway, pull up a new spreadsheet. And let's set that layout to, set for portrait. And insert. Let's see, insert picture, download, Trig Identities, and there you go. I know it's a lot of work. Some of y'all may have to push at least 3 buttons. Let's do no margins.
I have a quick question.
Yes, sir.
Isn't 10.4 and 10.5 on Unit 3?
Yeah.
Okay, but you
So
still
I'm
want
just
us to
putting
know
it,
it for Unit
I'm
2?
putting it all together because I want Unit 3 to be all focused on sine and cosine. So I don't want you to have to worry about identities in Unit 3.
Oh, okay. Thank you.
Yeah. So anyway, that's a good, I tell you what, why don't I save this for the 2 or 3 people that's going to print it out. Let me save this. Save as trig identities, maybe. Trig identity. And I'll put that on the do jigger. I'll send that to y'all. Give me a second. Documents, trig identities, and send. What the heck is that? Hold on a minute, there's something else here. What is that? I don't know what that other picture is. I'm sending it to y'all. Let me know if y'all get it. There's two pictures on there, and I don't know why there's a picture on there. I hope it's not a picture of my cats. My cat must have got up here and took a picture of himself. Did they send or are they sending? Okay, nobody's gonna say anything.
Here, I'll check real quick.
It said failed to send. Let me try to send it by itself. Hold on. Upload. That other picture may be messing it up. File already exists. Replace. Okay, now it's loading. Let me see if this will send.
I already see it on the files.
Okay, is it on there? See if you can pull it up and see if it comes up okay.
I mean, yes, sir, I see it. Okay. It's right in front of me.
All right, good. So for the 1 or 2 people that's going to actually print that out, that's a good little thing to have. And a lot of this is plug and chug. Okay, it's not. It used to be like for me, we had to memorize all these identities. Okay, and people nowadays they don't make you memorize them. All right. Now, there's one rule that you always need to remember about identities, and that rule is the following rule. And I'm going to write it in red. Whenever possible, always try to get in form of sine and what? And cosine. Now write that down, because whenever you're dealing with identities, you always, and not 100% of the time, but about 90% of the time, if you write the identity in forms of sine and cosine, it will help you out tremendously. Now, why is that? The reason it is because of these 3 identities. These identities right here, the tangent identities, and the reciprocal identities. Okay, as you can see, the tangent identities are written in terms of sine and cosine. And if you can get something written in terms of sine and cosine, you might be able to change it into tangent and cotangent. Sine and cosine also in the Pythagorean, also in the reciprocal. So if you can change something into sine and cosine, it might be beneficial to you. Now we're going to be working mostly with these top 3 or 4 identities first, but then after a while, you're going to start to see, well, heck, all you got to do is plug and chug. Just find one and plug and chug. And that's true. All right. So with that being said, let's look at the first section of 10.1, and I'm going to go to it, and we're going to look at 10.1. And you should be able to see the PowerPoint. And the reason I use the PowerPoint on Trig is because of all the identities. It's good to have it there so I don't have to go back and forth to the cheat sheet. That's why I do it. I don't use the identities, I meant the PowerPoints that much. Okay, and there they are. There's the 5 identities that you use a good bit, especially when you're first starting with identities. And that's the reciprocal identities and the quotient identities. I'm going to write them on my page here, and you should be writing them in your notes. The cotan is equal to 1 over the tan. The secant is equal to 1 over the cosine. And the cosecant is equal to 1 over the sine. Also, the quotient identities. Tan is equal to sine over cosine, and cotan is equal to cosine over the sine. Now, in physics, there's a couple of things that you should always know, like r sine theta is equal to the y vector, and r cosine theta is equal to the x vector. These are things, this first page right here is the things that you should remember in trig, because it's kind of like the basis, the floor. Okay, besides Oscar had a hunk of apple, okay, and besides doing the right angle trig, this is like the second floor of trig. So I would not suggest you memorize them. I would suggest that you learn them. Okay, I hate to say memorize, because that means after the test you forget them. Okay, I don't want you to forget them, because you're going to see them over and over again. Okay, especially if you go into calculus. Okay. They might show the Pythagorean next. I don't know if they're going to, yeah, they do. All right, so go ahead and write down the Pythagorean. You see these a lot in trig. I mean, not trig, calc. So sine squared plus cosine squared is equal to 1. 1 plus tan squared is equal to 1, or secant squared. And then 1 plus cotan is equal to cosecant. Now, it's not a big deal that you remember these, but if you want to write them down, it's not going to hurt you. Basically, the only thing you have to remember is that the cosine of negative theta is the cosine and the secant is the secant. The rest of them are the opposites. So sine is negative, cosecant is negative, tan is negative, and cotan is negative. You don't have to remember 4, just remember 2. Remember the cosine of a negative is equal to the cosine. The secant of a negative is equal to the secant. The rest of them you take that negative symbol and you put it out front of each one. Also, you can solve the Pythagorean identities for different things. If you want the cosine, well, cosine is equal to 1 minus sine. Tan is equal to secant minus 1. Cotan is equal to cosecant minus 1. So technically you have 6 identities right here. Now, let me get a show of hands. And I want you to keep your hands up till I tell you to take them down. Give me a show of hands on how many people have been introduced or have seen trig identities before. Let me see how many. And leave your hands up. I wanted to leave it for a second. I want to see how many people in the class have seen identities before. Pretty much half the class. Okay, you can take them down. So half the class has never seen them before. Would that be safe to say? Somebody volunteer, you've never seen the identities before. Okay, now okay, some of y'all that says you haven't, let me say you never had pre-cal before. That's a yes or no. Some of you that haven't had.
No.
Okay, you didn't take pre-cal? Okay. All right, well then that's where we're starting from. We got half the class that has had pre-cal and half the class hasn't, pretty much. Okay, we didn't do too much with identities. Okay, Mr. Parrish, that is very true, and I'll tell you why. It's kind of like completing the square. Teachers don't teach it because they don't know it. And that's why a lot of teachers don't teach completing the square, and a lot of teachers don't go into identities because they don't understand them or they don't like them. Okay, so that does happen in a lot of pre-cals. They just go over the good stuff. They don't go over the stuff they don't want to go over. Okay, so let's go to the next one. Express cosine in terms of tangent. Now, write this down because this is all identities are doing. Okay, identities are manipulators. You're rewriting. You're really not doing any math. Now, you do use identities to do math, but think of identities as rewriting a sentence. Paulie on Rocky, he had a very northern, some of you are from the north. Somebody in Rhode Island may say side by each. Okay, and side by each means side by side. Okay, but you reword it. And Paulie would say his lungs he'd punch out. Okay, some people would say that's abnormal. You would say punch out his lungs. Okay, so some of y'all got some terms that are backwards from other parts of the nation. So I know some of y'all from the north, right? Y'all know what side by each means? That means side by side. So anybody got anything they want to share? No. I kind of figured that. But anyway, when you rewrite a sentence, side by each, side by side, his lungs punch out his lungs. You are rewriting a sentence and it means the same thing. When you are using identities, you're rewriting a trigonometric identity in another form of a trigonometric identity. That's what you're doing. So if I want to express cosine in terms of tangent, I could just do it with the Pythagorean identities. cosine of x in terms of tangent. Since secant is related to both tangent and cosine, start with 1 plus tangent squared x is equal to secant. And you can take your handy dandy page here and let me get my bearings straight here. Okay, well, we'll just include this right here. So I'm going to rewrite cosine in terms of tangent. Tangent, theta, x, it doesn't matter what you use as a variable. So I'm going to use 1 plus tangent squared is equal to secant squared. Theta, x, whatever. Now, I can rewrite tangent as, okay, I can rewrite it this way either, because what they're going to do is they're going to use a reciprocal identity. Okay, so I could say 1 over 1 plus tangent is equal to 1 over secant. So 1 over 1 plus tan is equal to 1 over secant squared. Now, the reason they're doing this is they're going to get it in the form of a reciprocal identity, is what they're doing. And when they get it over the reciprocal identity, then you can rewrite it. So there it is. 1 over 1 plus the tangent is equal to, well, use your identity. Use your identity. Here we go. Okay, what is the 1 over secant? 1 over the secant, and we don't have it right here, but 1 over the secant can be written as 1 over the cosine. Okay, these right here, you do have the other ones over here. You've got cotangent, secant, cosecant. Well, where's the sine? Well, the sine is equal to 1 over the cosecant. Cosine is equal to 1 over the secant. And let's see, which one do I not have? Tangent is 1 over the cotangent. Okay, so those are reciprocal identities. Now, which one looks like 1 over the secant? Well, right here, 1 over the secant is equal to cosine. Therefore, 1 over secant squared is equal to cosine squared. And you can rewrite 1 over the secant squared is equal to cosine squared. So I rewrote 1 over the secant is equal to cosecant. Now remember, it says rewrite cosine in terms of tangent. So that means I want to get cosine by itself. And if I want to get cosine by itself, and I've got this as cosine squared is equal to 1 over 1 plus the tangent squared, then I take the square root, and cosine of x is equal to the square root of 1 over 1 plus the tangent squared of x. And you could actually simplify that, and that would be 1 over the square root of 1 plus tangent squared. But that doesn't matter, okay? There it is. Cosine is equal to positive or negative, and the square root of 1 is positive or negative 1, and then they got rid of the radical in the denominator. All right, so let's finish it. So I've got right here, I've got cosine of x is equal to the square root of 1 over 1 plus tan squared of x. Okay, so I want to get rid of the radical altogether, so I'm going to take the square root of 1 over the square root of 1 plus tangent squared of x. Well, the square root of 1 is positive or negative 1 over the square root of 1 plus tan squared of x. Well, I want to get rid of the radical in the denominator, so I'm going to multiply by the conjugate, square root of 1 minus the tangent squared of x. 1 minus the tangent square root of x, or square root of x. And you can just see that's it'd be plus, I'm sorry, be plus, my bad. Be plus. Because the square root of 2 times the square root of 2 is equal to the square root of 4, which is square root of 2. So if you multiply a square root times the square root, we don't have to do the conjugate. It just has to be square root times square root. The square roots are going to fall off, and you're going to be left with 1 times this is going to be positive or negative square root of 1 plus tangent squared of x over 1 plus tangent squared of x. And you don't need the positive or negative, so you can leave it, or you can just write square root of 1 plus tangent squared of x over 1 plus tangent squared of x. Now, again, I'm showing you this one because there's no math involved. Okay, all we did was rewrite. Okay, we took something like this. We took tangent and we wrote it in terms of cosine. Now, there may be another way you could have done it. There are different ways that you can do these identities. Okay, let me go ahead and say that right now. You may be able to use a reciprocal identity and then put in the Pythagorean identity and then come out with the same answer, only a different way. And that's fine as long as you do everything correctly. The same answer is the same answer. Okay, there are other ways. But in this case, they went with the reciprocal identity. I'm sorry, with the, what one? I can't get rid of the, there. They went with the Pythagorean identity first. Now, how did they know to use this? Well, they had to find something with a tangent in it. So you could have done, let's go back to the identities that we wrote down so far. Okay, this has got tan in it, but it goes to cotan. That don't help us. Got tan right here. We could rewrite tan in terms of cosine. Yes, you could. Okay, but you might have to, that could be a way to do it. And the only other is right down here. So you probably could, let's see, but the only problem with this one is it's got sine in it, and you would have to get rid of the sine. This one, a lot of people say, well, Hubert, that tangent is not written in terms of sine. Yes, but the secant can be written in terms of cosine. So you kind of have to think, kind of like chess. You have to think a couple of moves ahead. Okay, so you need to think about, rewriting and thinking of secant. This is not a problem I would have started out with. I would have started out with one a little bit easier with sine and cosine, but that's just me as a teacher. But don't worry, you're gonna get so much homework out of 10.1 through 10.3. Don't worry, you're gonna get used to it. And that's all I'm concerned with is 10.1 through 10.3. So let's try another one, or let's move on. So okay, write tan or cotan in terms of sine and cosine. So I'm going to write this down. Write tan of theta plus cotan of theta. And they want it in terms of sine and cosine. Well, that's true. That's the rule. Try to write everything in terms of sine and cosine. Well, I know that tan is equal to sine over cosine. And I know that cotangent is equal to cosine over sine. Well, I'm multiplying, I'm adding, I got two different denominators. So I'm going to make the denominator cosine sine. Now, this is using your common denominator skills with fractions, which a lot of people suck at. So that's why they suck. I'm sorry, what?
We can't see your board.
I'm sorry.
It's okay. You're all good.
I know. I just get irritated. Okay. So here, this is the only thing identity-wise that you're using. This, what I'm doing right now, comes from 3rd, 4th, 5th grade mathematics, finding the common denominator. Common denominator, because we're adding, is cosine sine. Well, cosine will go in here, sine times sine is sine squared theta, plus sine will go into cosine sine, cosine times cosine squared theta. Hey, sine squared plus cosine squared is equal to 1. Cosine theta, sine theta. This is what I would have started you out with on the slides if I didn't write the slides. This is what I would test you on right here. This is the first problem that I would show you on 10.1 through 10.3. Now, how did I know to do this? Well, the age old, when I was at Clemson and I took trig, that's what I was told the first day of class. Well, not the first day of class. The first day of the 2nd or 3rd unit, whichever was identities. Dr. Ruckle put that on the board. He said, we're going to start identities now. And everybody needs to remember this. Whenever possible, always try to get in the form of sine and cosine. And he wrote that on the board the first day of identities. So Dr. Ruckle, he was about 6'3", about 400 pounds, and he played Tetris all the time. And he quoted physics and calculus like you and I talk. I mean, he was a very interesting man. He kind of remembered me of Ollie on Andy Griffith Show, Uncle Ollie. If anybody ever knows the Andy Griffith Show, Uncle Ollie, that's what Dr. Ruckle reminded me of. He's not like Dr. Harden. Dr. Harden grunted. Dr. Ruckle didn't grunt. He just talked. All right, so that's a good test question right there. Yeah, he would sit in his office and he would have his back to his office. And anybody ever seen Clemson, the math instructor's office? It's about like 8 by 6. I mean, their offices were like little cubby holes. And he would sit in that office, and he had the desk facing the fountain or the amphitheater, and because the window would overlook the amphitheater, and his back would be to the wall, and he would be in there doing Tetris, and I would knock on the door, and he would jump out of that seat because he was so into Tetris that he would forget about everything, and you knock on the door, it scared the crap out of him. And I hated to do that to the man because he was an older gentleman. You know, he was everybody up there that teaches like 100 years old, and I scared he's going to have a heart attack. All right, so that's a good problem right there. Let's do a nerd. Or let's see what's next. Let's see if that's what they did. Sine over cosine. They got a common denominator. Yep. There it is. Those are the kind of questions I like to put on a test. They're pretty straightforward. They're not a lot of, trickery. So learn the fundamental identities. That's what I just showed you. Those 6 to 9 identities, those are the fundamental identities. Try to write the more complicated side of the equation. It is often helpful to express functions in terms of sine and cosine. And usually any factoring should be performed. Okay, so there's little hints to do the next. Now these next series of problems, they're going to set up, it's going to be an equation, and it's going to have an equal sign, and you need to pick a side. Now, of course, they want you to pick the more complicated side because it's easier to work with the more complicated side in some of these. Okay? There's a couple more little hints. And you can take a second to write those down also. And you can look these up under Google, hints for verifying identities. You can look them up, or you can go to the resources tab and pull this PowerPoint up. It's there for you to have also. Okay. So here we go. The cotan, I'm going to write it down and then I'll show it to you. Cotan of x plus 1 is equal to the cosecant of x. I can't write today. The cosecant of x times cosine of x plus sine of x. Right? So, what are we going to do first? Well, I would take the right-hand side and I would change that cosecant to 1 over the sine. Now what? Distribute it. Cosine of x over the sine of x plus the sine of x over the sine of x. And what is the cosine over the sine? And what's sine over sine? Ding! No math involved, just algebra. What do you mean, just algebra? Well, I distributed. That's the algebra. And then I just use trig to change it back. into that. This is another good test question. This is the type of question I would ask on a test. Okay, some of you that never had identities before, any questions? Do you see what we're doing? We're basically rewriting / manipulating trigonometric sentences. You get it now? Does that mean a light come on, Miss Holcomb? Wow! And now, Miss Holcomb, did you have trig before, or have you had identities before? Oh, you didn't. Okay. All right. Let's try nerd. How about, I'm just writing them down so I don't forget to show y'all this side. So okay. So we got tan of t minus cotan of t. Why do they use t? That's so stupid. Okay, we're going to change this. Secant squared of t minus cosecant squared of t. We're going to change this. Why would you use t with tan and cotan? Let's use theta. Tan of theta minus cotan of theta over sine of theta cosine of theta equals secant squared theta minus cosecant squared theta. Now, what side do you think I'm going to work with? Anybody have any idea?
The left one.
The left one, because you got a fraction. Exactly. So I'm going to try to get that. Now, I want you to focus on this right here and see what you can come up with. Remember, most of your rules here are going to apply to fraction rules. Then once you do something with this side, then you can revert back to your identities. First, you got to use your fractional rules. Well, what do you mean fractional rules, Hubert? Well, if I got, this is the common denominator, and I've got tan minus cotan, I could rewrite this as the tan over sine cosine minus the cotan of sine cosine. And I'm sorry, when I'm working with identities, I don't write theta 5,000 times. So if I'm offending some of y'all by not putting theta on each one of these, then I'm sorry. But I think when you're doing scratch work, when you're doing the work, you need to just focus on the identities and the fractional rules and the algebraic rules. And then when you get finished, make sure you put a theta in the problem, in the answer. Okay, I'm not going to worry too much about that. Okay, so I can rewrite this, and then I could maybe, remember, if I could get tangent and cotangent, maybe I could rewrite those as what? Sine over cosine and cosine over sine. Yeah, maybe. Let's try that. Let's try here. I'm going to make that sine over cosine. So I'm going to do that in another color. I'm going to rewrite tan as sine over cosine. And I'm going to rewrite cotan as cosine over sine over sine cosine over sine cosine. And we aren't subtracting. Well, I am dividing a fraction by another fraction because this is sine over cosine over 1. This is sine over cosine. So I can multiply both of these by the reciprocal, can't I? So that's going to give me sine over cosine and cosine over sine multiplied by, well, if this is divided by sine, that means I'm going to multiply by 1 over sine cosine. All right, now I want you to finish it. You should be able to finish it. I've done the hard work for you. Somebody tell me what happens on this side. What happens here?
The signs cancel out.
The signs cancel and tell me what you're left with.
Cosine. 1 over cosine.
1 over what?
Cosine squared.
Oh my goodness, that may be an identity. Somebody tells me, I don't know what's wrong with me. Somebody tell me what happens on this side.
Cosines cancel out.
And you're left with
1 over
1 minus, or minus what? 1 over sine squared theta. And what's 1 over cosine squared?
secant squared.
Oh my gosh, look at there. And 1 over the sine is the cosecant squared. That's all there is to it. Now, this is not difficult. It's kind of like a Rubik's Cube or the horseshoe puzzle, you know, where you have 2 horseshoes with a ring on it and 2 pieces of chain, or you know, some of those puzzles that you get, like the golf at Cracker Barrel. You know, the triangle with the golf tees on it? That's what these are. If you suck at those things, then you're going to suck at these, and you're going to have to work harder. If you are great at those kind of things, then you're going to get these a whole lot quicker. Because you're starting with something, and you got to rewrite it like that side. And you've got to use these fundamental identities to do it. All right, let's do another one. I'm trying to find one. Hold on. Okay, here's one. Wait a minute, let's see. Well, this one is, you can use either one. Cosine of theta over 1 minus sine of theta is equal to 1 plus cosine of theta over, 1 plus sine of theta over cosine of theta. Now they want you to prove one side or the other. It doesn't matter. I'm going to pick the right side. I'm going to pick this side. And I'm going to see if I can rewrite it to make it look like this side over here. Now what can I do? Well, in algebra, we learned about what? The conjugate. I have to say it in my head 3 or 4 times before I say it, because conjugate, and I don't even know if I spelled it right, but I have to say it in my mind to spell it right. So somebody Google it and make sure I spelled it right. I always want to put an N in conjugate, but I think it's conjugate, because I think you do it in English also, and you do it in math, and that's all I'm going to say about that. Okay, so somebody check it, make sure I spelled it right. And the conjugate of 1 plus the sine is what? What's the conjugate of 1 plus the sine? 1 minus the sine. So I'm going to take this guy, 1 plus sine theta over cosine theta, and I'm going to rewrite it using multiplying by the conjugate. Okay, that's using algebra. And what gave it away was this 1 plus the sine. Now you could have done it down here and did 1 plus the sine over 1 plus the sine, and then change this. But I chose this side just because, I don't know, I just chose it. And that's going to give you difference of 2 squares, shortcut number 3, still doing algebra. So that's going to give you 1 minus sine squared theta over cosine theta times 1 minus sine theta. Well, 1 minus sine theta, hold on, where's my dang old identities? I got them here somewhere. What is 1 minus the sine squared? Well, if I sine
Cosine
or
squared.
cosine is equal to 1 minus sine squared. So I can rewrite the cosine as 1 minus the sine squared, or 1 minus the sine squared as cosine. So I'm going to change that to cosine squared theta over cosine times 1 minus sine theta. Somebody tell me what happens.
You can cancel out one of the cosines.
Okay, this cosine by itself will cancel with one of these and just leave cosine, and that's going to leave me with
Cosine theta.
cosine theta over 1 minus sine theta, and that's what we wanted. So what you need to do when you're tackling these is think of a Rubik's Cube, or think of a horseshoe with 2 chains on it with a ring on it, or the little triangle with the golf tees at Cracker Barrel. You either are going to do it one time and quit, or you're going to keep doing it until you eventually get it. And it's all based so far on those, what, 6, 7, 8, 9, 10, 11. Those 11 identities right there. Let's see if we got another one. Well, I'm looking to see a good one. I'm trying to pick out a good one. I don't like that one because that one you got to assume a whole bunch.
I have a quick question.
Yes, go ahead.
Did you send out the 9.6 homework yet? For
I think I
my
did
labs
this
class?
morning.
Okay, just wondering.
Yeah, have you checked it since this morning?
No, sir, but I will right now.
Yeah, go ahead and check it and make sure it's okay.
I saw it in there this morning.
Okay. I'm checking this one right here. This one, let's see. 1 plus a sign, 1 minus a sign. Let's see. What they're doing with this one, let's see, they're writing, I'm going to give you this one probably we're going to probably, let's do this one. This will be your first homework question. This one says secant tan, secant plus tan over secant minus tan is equal to 1 plus 2 sine plus sine squared over cosine squared. Now, of course, all those have thetas in them or alphas or whatever. And they're picking the left-hand side. They're picking this side, and they want to make it look like that side, the right side. The first thing I would tell you to do on this problem is multiply by the cosine over the cosine with this right here. Now, I guess you could probably do the sine also, but the reason I picked the cosine was because of the secant or the tangent, because you can rewrite tangent with the cosine on the bottom. And that's what I'm trying to think of. And secant, that's the, yeah, that's because both of these have a relationship with the cosine versus the sine. Sine is 1 over cosecant. So, and yeah, I think that works out better since both of them have a relationship. That's what I would do. And that would be cosine times secant plus tan over cosine of secant minus tan. And now you would distribute the cosine, and that would give you secant cosine plus tan cosine over secant cosine minus tan cosine. Now, if you rewrote the first part of this, that would be 1 over the cosine times cosine. 1 over the cosine times cosine. That would be 1. But I'm going to write it as a baby step right here for you. I'm going to rewrite that secant as 1 over the cosine and 1 over the cosine times cosine times cosine minus tan cosine plus, I'm sorry, be a plus and a minus tan cosine. And of course, you see the cosines go out. So that's going to leave me with 1 plus tan cosine over 1 minus tan cosine. And now you can put everything in terms of sine over cosine. So 1 plus, I'm going to use another color. I'm going to use this turquoise. Sine over cosine and sine over cosine here. Times cosine times cosine 1 minus. And what happens to the cosines? So you have 1 plus the sine on top and 1 minus the sine on top.
Multiply by a conjugate, maybe?
Well, you know, that would give you, well,
Because you need that. Would you not use like a Pythagorean
Yeah.
identity at the bottom?
yeah, you could.
And then
That would give
just,
you 1 plus the sine on top and bottom. Yeah, and finish it out with that. Now, the 1 plus the sine is going to give you shortcut number 2 or 1 on the top. Let's go to the next page. So I've got right now, I've got 1 plus the sine over 1 minus the sine. Now I'm going to do, just like he said, multiply by the conjugate. 1 plus the sine and 1 plus the sine. Now I'm going to write this out. I'm going to expand it because I don't want you to get confused here. Okay. The bottom, we have shortcut number 3. The top, we have shortcut number 1. So I'm going to expand it. On the bottom, we got 1 squared minus sine squared, basically. Shortcut number 3. On the top, we have 1 plus sine quantity squared, which is shortcut number 1, which is going to give us 1 plus 2 sine theta plus sine squared theta over 1 minus sine squared. And when you get that, you get the left-hand side. And if you remember, on the problem, we wanted this side to look like this side, and I forgot the cosine squared. 1 minus sine squared is equal to cosine squared. Sorry, I forgot that part. That's a good test question also. Now, let me ask a question, and I know it's about time to go because some of y'all are convulsing. Okay? Those of you that have seen Identities, was that a good kind of review? Let me see your hands. Was that a good review over fundamentals? Out of the 10, let me see. Okay, we got 6 out of 10. All right, put your hands down. All right, out of the 10 that have never seen, how many of you have a good indication of what we're doing as far as rewriting? Out of the 10 that you've never seen it before. Okay, we got 3. So some of y'all, 4. Some of y'all are going to have to let it. Okay, let me hear from, put your hands down. Some of you that didn't raise your hand, you got to let it sink in tonight and go over some problems. Is that what you need to do? Let me know. Yes or no? Okay, nobody's going to say anything. It's always good to have a class that don't communicate. That's good. That way the teacher has no freaking idea what's going on, but that's okay. Anybody got anything they want to say about the fundamental identity so far? I appreciate y'all's communication. Those of you that are communicating, I appreciate it. Okay, let's go to the handy dandy. Now, right now, y'all should be working on 10.1 pretty much. Okay, I'm not going to make you, I mean,